Let us look into how the Steeler plate has been defined in the ship's construction. Before going to Steeler plate, we should understand what is strake. Strake. You know that the ship's hull is the complete hull, the side shell plating and everything. The shell is made up of steel plates joined together by welding. So these plate is not a complete one plate which is running straight from stern to bow, but a number of plates are arranged in rows, one row, two row, three row, four row, and longitudinally also one, two, three, four, from astern to bow. You're arranging the plates and welding it to make the complete shell of the ship. How the strakes are? So these plates, so those plates which we're talking about are the strake. Each individual plate is given the name strake. But how to identify or how to name the strake so that you can identify easily if somebody is saying you go and check A5 strake. So you should have a knowledge of that. So in this table, it has been shown or represented in a simple way. If you notice in this row, the bottommost row, all strakes are given a name of A. Number one from astern is A1, then just next to that is A2, just next to that is A3. So that way it is running from astern to bow. When you go up, so next row is B1, B2, B3, B4, B5, B7, B8. So this is B row, this is A row of strakes, this one is C row of strake, and so on. D row, and numbering is from up to forward 1, 2, 3, 4, 5, 6, 7, 8, like that. Ship cross section is not uniform throughout. You know it very well that in the bow section and in the stern section, the cross sectional area of the ship is reducing drastically. So when you arrange the plating like this, you will found or you will find a situation in the bow area, bilge area, or in the stern area, the width of the strake plate is very less. So if you have two row like A and B row on top, and it is running towards the aft towards the astern section, the cross section area is changing. So your strake width will not be uniform, it will be tapered. So geometrically, you will reach to a situation where you will find that there are some points where the streaks width will become almost zero. So suppose A streaks width is reducing and reaching almost zero, and B streak also reducing and width is reducing and reaching to zero or approaching zero. And these two plates are welded at the end. So it will be a very, very small area which is being joined together by welding. So how to avoid that? So you can understand here by a simple diagram. This you can see is the D13 streak of 13.5 mm plate thickness. This one is C13, that is 13.5 mm thickness plate. Now, next streak, if we would have continued like this, so what was happening? It is going down. And this one is also like this. So you can see if we would have used D14, the width of the streak was very, very less. It's almost zero. So what will happen because of this? The strength in this area will become very less. So it will be a weak section. So how to avoid that? To avoid that, what is getting done? Instead of continuing D13, then D14, C13 and C14, you replace it with one plate of higher width and join together with these streaks. So what does this mean? You have missed D14 and C14, right? So that is why this plate is called the Steeler plate. You can also notice that since we have increased the width of the plate, the thickness of the steel has reduced 12 millimeter. So it means by inserting a Steeler plate, you can reduce the ship's weight by reducing the thickness. So wherever it is needed. It is not that in all area you will use the Steeler plate. Then also it will be a problem. So wherever the streak's width is getting thin, width is getting lesser, and approaching almost zero, in those location, you use a Steeler plate instead of continuing the streak like this. For the practical example, you can see it over here. You see here, this is A row, A1, A2, A3, A4, A5, A6. This one is B1, B2, B3, B4. This one was C1, C2, C3. Here it is B5, B6, B7 like this. But what is happening? just before B5, you see that this, if we continue using this strake, the strake width will become very less. So instead of doing that, you have merged C strake and B strake together to get a wider plate and join to make the structure stronger. So this is basically the concept of steel plate. You can go through the write-up over here. Steel plate is an extra triangular or wedge-shaped plate inserted in the cell plating of a ship where the normal arrangement of plates cannot be continued. Location in those ships area where the cross section area changes drastically, like bow area, stern area, and bilge area, bilge region. Bilge region, I think you are understanding what is bilge region. If this is ship's hull, this is bottom plate. So this area is the bilge area where the section is changing. Cross section area is changing. This area here. Purpose: as the ship's hull curves towards the bow and stern, the spacing between sail plates changes. To maintain proper plating arrangement, steel plates are inserted to fill the gap. Functions: maintains proper plate arrangement, ensure structural continuity, reduces plate distortion, improves hull strength. And what kind of shape of this steel plate? It can be triangular or tapered plate, and gradually merges into the surrounding cell plates. So this is the write up. So hope you understood the concept of steel plate. Thank you.